All right. Here we have June 2020 chemistry paper 3. This is group 3. So we are going to analyze the paper together just for titration. Okay. So question 1, it reads, you are provided with the following solution K, which is aqueous sodium hydroxide, solution L, which is dilute sulfuric acid, solid sulfamic acid, and phenolphthalein indicator. You are required to prepare a standard solution of the sulfamic acid and use it to determine a concentration of sodium hydroxide. Then later you use the hydroxide to determine a concentration of sulfuric acid solution. The previous experience of this type of exercise is not required normally because full details on the procedure. So we are going to do the procedure together, and then now I'm going to show you how to perform the calculations provided you have values. So for the procedure, the first one is you have to weigh accurately between 2.25 gram and 2.35 gram of sulfamic acid. Generally, most at times when you get to the lab, it has already been weighed. It has already been weighed for you, and you just see it in the plastic cup. That's a film cup, and the mass written on it. So if not, then you have to weigh it yourself. But anyways, when you weigh, you record your mass and you weigh using electronic balance. Now, after weighing, what you dissolve it in distilled water and you make up to the mark in a 250 cm cube volumetric flask. You record the mass in table 1. So this is table 1. You go to the third line, which is the mass of sulfamic acid weight. You measure the mass, you write the answer of the mass. So make sure you don't write grams again because the unit is already given. Now in the first two lines, you just write third. Okay. Now, still in the first procedure, you're actually preparing a standard solution of sulfamic acid. What was given to you was solid sulfamic acid. So what you do is that when you maybe the sulfamic acid given to you is in a film cup, right? You take water, you pour into the film cup, you use a stirrer, you stir it so that it dissolves. Then your volumetric flask is there, use a funnel, then you transfer the solution in the film cup into the volumetric flask. You make sure you rinse the funnel, you also rinse the film cup, you also rinse the stirrer, and then you make it up to the 250 centimeter cube mark, and then you shake so that everything should be uniform, right? Should have a uniform solution. That is it for the preparation of the standard solution. Now let us go to the second instruction. By the means of a clean pipette, transfer 25 cm cube of sulfamic acid solution into a 250 cm cube conical flask. Then you add 2 to 3 drops phenolphthalein indicator and titrate with the solution K to the endpoint. Then you record your results of 2 careful titrations in table 2. Now, table 2, we have the burette reading where you have the approximate and 2 accurate. So, according to there, you have the first burette reading. So, according to the instruction number 2, you need to use a clean pipette and you transfer 25 cm cube of that your standard solution you prepared into a 250 cm cube conical flask. So, you know how to pipette. You pipette 25 cm cube of the liquid or the liquid sulfamic acid of the standard solution. You pour into the 250 cm cube volumetric no conical flask. Then what do you need to do? You need to add 2 to 3 drops of phenolphthalein indicator. Once you add that indicator, the color of that standard solution automatically changes. Then when you do this, you now titrate what you have in the conical flask with solution K. Now solution K is normally aqueous sodium hydroxide, and if you're titrating with sodium hydroxide, it means sodium hydroxide is the burette. So you need to take sodium hydroxide, you fill the burette with to the zero level, and then you start your titration. Remember that the acid is in the conical flask and the base is in the burette. So when you're tight and the indicator used is phenolphthalein, and this phenolphthalein was added to the acid. So once it's added to the acid and you start titrating, the phenolphthalein, when you start titrating with the base, the color will change to pale pink. So that is the color at the end point. So when you see a pale pink color, you stop and then you record. The first burette reading is the volume you're recording in your table is the volume of the sodium hydroxide that has been used. Okay, so the first burette reading is 0.0. The burette measures just one decimal place, the precision, so it is 0.0. Now the second burette reading will be what you have. In fact, after the first titration, the first burette reading is 0.0. The second burette reading is the volume of sodium hydroxide used to obtain that pale pink color. You record the volume and then you can refill. That is, you're still under approximate. Now you can refill the burette to the 0 cm cube mark and then you go to the accurate. Okay, now for the accurate, once you refill, your first burette also be 0.0, provided you filled it to the 0 cm cube mark. Now you titrate again, you perform the same thing again. That you see pipette 25 cm cube of the sulfamic acid to the conical flask, then you add 2 to 3 drops of phenolphthalein and then you titrate again. And then when you see the pale pink color, you stop. Then you record the second burette reading for the accurate one, and then it is needless to carry out again 2 times. So if that's why you need to carry it for the first time accurately, so that you just replicate or duplicate the result and you fill in the second one. Now the mean titer is accurate 1 plus accurate 2 divided by 2, and make sure your answer is to 1 decimal place. For example, if you have 4 plus 4 plus 7, maybe 4.4 plus maybe 4.4 plus 7.2, or maybe let me say 4.5. Yes, 4.5 plus plus 9 gives you 13.5. 13.5 divided by 2 will give you 6.75, I'm sure. But don't write to 2 decimal place. Make sure you write to 1 decimal place, because the burette has a precision of 0.1 cm cube. Can measure only to the nearest 0.1 cm cube. Okay, we are done with the table 2. Now let's go to table 3. In table 3, let's go and read the third instruction. Now in the third instruction, using a different burette, place 25 cm cube of solution L into a 250 cm cube conical flask. What is solution L? Solution L is dilute sulfuric acid. So if you don't have another burette, you can just maybe use a pipette, and you pipette 25 cm cube of the sulfuric acid and you put it into a conical flask, or you use a measuring cylinder to do that. Now when you do that, what you need to do next is that you need to you have 25 cm cube of the solution in the conical flask. Now you add 2 to 3 drops of phenolphthalein indicator and you titrate with solution K. Solution K is aqueous sodium hydroxide, and it is still supposed to be in the burette, and the acid is the base is in the burette and the acid is in the conical flask. So when you add the phenolphthalein indicator, it changes the color of the acid. Then when you start titrating with the sodium hydroxide, the endpoint color is pale pink. Now you do the same thing like I explained previously, and you record your values into 3, and you find the mean titer 2, and that is the volume of sodium hydroxide that reacted with a 25 cm cube of sulfuric acid. Now for the calculations, what you have to do is the first question is calculate the concentration of sulfamic acid solution. Sulfamic acid is a monobasic acid and the relative molecular mass has been given as 91.7. So since sulfamic acid, you prepare the standard solution, the concentration will just be the moles over the volume in dm cube. The moles is the mass on the molar mass, and the mass is what you measured, and the molar mass has been given. The volume in cm cube is 250 cm cube. That was the total volume of the sulfamic acid. So the volume in dm cube will be 250 on 1000, which is 1 divided by 4, 0.25. So you just use molarity equal to moles on volume. We have the volume as 0.25 dm cube. The moles is a mass on the molar mass. The mass is what you measured and the molar mass has been given. Doing that, you're going to get the concentration of sulfamic acid. Now, to calculate the concentration of sodium hydroxide using titer 1. Titer 1 is basically the volume of sodium hydroxide that was titrated with the sulfamic acid. So since you was an acid based titration, you need to use MAVA on MBVB equal to Na on NB. Na is 1 and NB is 1 because the number of moles of the acid and the base in the balance equation. Now Ma is the molarity of the acid which was calculated in equation 1. Va is the volume of the acid which was titrated, which is 25 cm cube. Mb is what you are looking for, that's the molarity of the base, and Vb is the volume of the base, that is the answer of titer 1. You just replace and you get the answer. Now in question B, we need to find the concentration in grams per dm cube. So you can use your inference book to get that. The concentration in grams per dm cube is a relative molecular mass times the concentration in mole per dm cube. So doing that, you're going to have the concentration in mass in grams per dm cube, using the fact that the concentration in mole per dm cube is found in equation 2a. And using titer 2, calculate the concentration of sulfuric acid solution. Now titer 2 is the volume of sodium hydroxide that reacted with 25 cm cube of sulfuric acid. So you need to first of all balance, you need first of all write the neutralization reaction since you are reacting an acid and a base.